Hello everybody! Woo. Hey, welcome back to another shopping haul. I've been again to the electronics store and I bought a lot of stuff that I want to share with you all today. How is everybody doing? By the way, thanks so much PPC Benny for the Prime sub while I was not streaming, and Lewis Arden for the Prime sub. So, I again spent more money on unnecessary stuff. I got a huge box today down here, but we won't be looking at everything that I ordered, just what is in this bag today. Okay. Alright. Okay. So here's all the crap we want to look at. Where's my stream deck? There we go. Yeah, welcome back. How's everybody doing? Okay, alright, so what did I order? Okay, so there were a couple of things that I was unsatisfied with the build so far of our 8-bit computer. As you know, we had this huge potentiometer, which is like super ugly kind of looking for the build. It was also a bit too big, so that's something I wanted to replace. You know, I've been unsatisfied with the switch that we were using. There are these tiny switches to switch between things, and Ben Eater had these nice push buttons. So that's also something I didn't like and wanted to deal at some point. And then you also know the story about the blue LED, which, or let's say on the other colorful LEDs, we replaced them with these flatheads because they look so much better on stream. So as you can see, these LEDs have a flat head. And I wanted a blue version of these as well, but the German store didn't have these kind of blue versions. So what we did is we used another blue LED and used a saw to saw up the top. Didn't look so great, so we also wanted a replacement for that as well. So I went onto a larger distributor store again, and I looked through the store and bought various different kinds of like switches and potentiometer and other LED stuff just to explore what is possible. As you know, I haven't really made a parts list available yet. This is, for example, part of the reason why I wanna share exactly the parts that make up for a really cool build. So today we have, for example, here switches that we will see if they can fit and if they work nice, and what the deal is. I found blue flat LEDs, indeed, and they were damn expensive. I also found other kinds of LEDs that I will show in a moment as well, and some other weird stuff I saw that I just bought too, just to explore this. So basically that's the idea for the stream, at least for the start now, that we just go over the stuff that I bought here and have a look at it, and if it maybe fits well for our build or not. And then I definitely also want to look at what Toby mentioned about the about the I try to do a pull up resistor or whatever I tried to do, and it didn't work, and it just didn't work. And Toby apparently understood what the mistake was and said that he made a simulation why it's wrong. I'm not sure how I would reach that, but that's definitely something I hope also to look at some point. Toby, please let me know how that would work. Are you fine with LT spice files? I have absolutely no clue what LT spice files are. If you tell me what kind of apt-get install command I have to type into my Ubuntu, then it's all good. Okay. Crap, I forgot to turn this camera here on. 1 second. We'll make screenshots. It's a simulation tool. Is it easy to install, or aren't pull up and downs really easy? Well, thanks for making me feel really good today. Yeah, I guess they are easy. I thought they were easy. But I guess I did it wrong. It's only for Mac and Windows. Okay, that makes it a bit unfortunate right now to run. You can make screenshots, or you can also just make a quick recording, upload it to YouTube, share the link, and then we can watch it or something like that. I don't know. But yeah, let's do this first. While I commissioned the work of creating a YouTube video about what I failed with. And I guess, let me, how do we do this? So I put this now all, I guess, over here. The bug which is discussed in Saelo's frag paper was patched in Nintendo Switch since the first version. However, they reintroduced it They reintroduced it? That's kind of weird and interesting. How did that happen? That's weird. Did they downgrade again, or why did that happen? What's your daily driver? I would probably say Mac, but I use everything here. This is an Ubuntu machine. The stream is running on a Windows machine, and I have a Mac here to chat. So, you know. All right. Okay. First package, I guess. This is. Let's put this here. Oh, I turned this. Second. Transform, rotate. All right. So maybe we can do it like that. No, it's my face. I guess that is good. All right. This is an unboxing channel now. Exactly. Do we need the music again? I also need to hear the music. Okay, so what do we have here? These are dip switches. Oh, the light. Dip switches. So I bought here these blue dip switches because they have different kinds of levers, as you can see. And so they stick out more. And I was wondering if that's maybe nicer just for our build here. If they stick out more to select stuff. That's easier with the finger, I guess. Also, I think they move way easier. And I just realized I forgot to order a 4-pin dip switch. This is an 8-one. I'm an idiot. But yeah, I think that is actually, much nicer for selecting at least. But maybe the color concept now doesn't match. So maybe we still need to, change that. But yeah, we could plug that in here. And now we have these switches. I think that looks neat. And I think maybe that's easier to move as well. Yeah, let's keep that in here for now and store these others away. Deep switches. That is so weird that they have newer bugs. I mean, yeah, but it reintroduced that bug. Was it then also reintroduced in WebKit itself? I mean, that must have been reintroduced in WebKit itself, or are they working on some weird fork where they are really changing around a lot? It's kind of weird. What do you have? A MacBook? Just a standard MacBook Pro. I mean, there's not much. There's just one. It's a 13-inch. I don't like 15-inch. For now, we just follow Ben Eder's series, so we will programming it by hand. But I might want to implement a programming interface with an Arduino. I think that could be also fun. Anyway, on to the next one. So what do we have here? These are latching E-switches. Look at this, how they order this. Like they put it in a bag and then they add even a tape seal to it. Oh, I don't have an opinion on Google Apple Pay. You can pay stuff with. Seems fine. Okay, so here we have a button. Now, like I said, this looks more like Ben Eder's button that he used. This is described as an E-switch latching. Okay, so this, as you can see, you press it once and then it stays down, and you press it again, it comes out again. So this would be one of these possible switches that we can replace our clock selector and also our address selector here. All these switches where we go back and forth between two states, this could be a nice replacement. However, I think, yeah, and that's the problem. If you look at the breadboard and the spacing for it, so these pin spacings are just a tiny bit. Wait, let me get us another breadboard. So these legs are just a tiny bit too narrow, I feel like, or are they? I guess they still could. You can. Okay, they still fit. It's like a tiny bit. I think the spacing is just slightly off. Oh, look! It just falls out again. It has some pressure on the edge. It just doesn't go fully in. So these ones don't really fit on the breadboard. That was a concern I had because they have the measurements in the data sheet, of course, but just like you know, with these kind of things, they are like just like 2.5 something millimeters apart, these holes. So if you are just off by half a millimeter, that makes a huge difference. What's the best way to support me? Thanks for asking regarding the fees. And to be honest with you, I don't care at all. There are these different options because people like one thing over another. I feel no way regarding one whatsoever. If I would feel like that something is so inefficient that it's not worth it for me, then, or you know, like that I think it's too much, then I just wouldn't offer those kind of ways. So whatever seems easier for you. If you have, I hope you have seen my video. It's also, I think, linked on the Patreon where I kind of explain the different concepts of if you want to support per video or per month. And so I guess Twitch and YouTube would be an option to support per month with a subscription. On Patreon, you can support per video on the main channel, so not the joke videos that I upload on the second channel or other stuff. It's just like these typical Live Overflow videos that I make. If you want to support these kinds of videos, then Patreon would be your choice. And if you just want to do a direct thing, then there are also like a one-time direct thing. Then there's also the bits on Twitch. You can buy bits on Twitch and then spend them on streamers. What's the second channel? It's just Live Overflow 2. Oh, otherwise you could use a Dauertag. Yeah, I haven't, like, that's also why I don't have like PayPal donations and anything like that because, okay, wait, we need to order this. So this one was not so great, so I guess we throw this away. So I haven't figured this out yet because my accountant said they don't want a lot of small transactions to deal with and to do the accounting work for it. I mean, a lot of other people do it, so I think it's just making them understand how to use PayPal because they haven't like used it much. So yeah, I need to talk to my accountant how this all works, and then maybe I can do that as well. Yeah, I'm coming to C3 for sure. Thanks for the 42 bits. Yeah, like always, like every year, if nothing major or bad happens, I will be there. Okay, so we have another version of the same switch, basically, just a little bit larger, and it's also a latching switch. And that seems from the spacing and from the size a bit better. Yeah, this just seems to just fit right in there. Let's see. Oh yeah, that is very strong in there. That's a cool switch. I like that one. Okay, so we leave it on here. That's a good choice for a switch. We need to remember is this one. Okay, so this was a DPDT latching. Yeah. Once I know which ones are the good ones that are cool for a build, I make sure to... oh, I forgot this one here. Oh, crap. Oh, no. I will share this on the parts list. What's the commission for creator on Patreon? I totally forgot. It's pretty high. It's maybe like 10% for Patreon or so. Look in the FAQ. It should be public. It should be there somewhere. Okay, so these were the small ones. These ones are the big ones. Yeah, small ones right there. Big ones, I guess we leave for here now. Is the breadboard 2.5 for... Yeah, so this is standard breadboard size, exactly. That standardized hole width. Okay, these are potentiometers. So these should be, let's see, these should be 1 meg. It doesn't say on here. Does it say on here somewhere? It only has this label here at the bottom, B105HD. It doesn't say, but it should be 1 meg. The spacing on there might also fit. We could bend these away and then it should fit. And that's a nice looking one. I think that one looks nice and has a pretty small footprint. Let's quickly measure the ohms. I guess in the middle is ground, maybe? Yeah, 1 meg ohm is the maximum of this one here. So this one looks really nice. Let's see. Are you sure that Linus's exploit doesn't work on there because of remove sticky bit? Because if I remember correctly, the switch doesn't have JIT. It doesn't. The browser is not jitting. That's why JIT bugs obviously don't work. I thought that was the case. Okay, so let me bend now here. Maybe because I lean forward like this all the time, should I put this maybe over here? Yeah, that might be better maybe. So I'm bending. So these are the legs that would hold, that you could use to hold it in place on a real PCB to remove strain from the connections here. So let's see. Okay, maybe we need to cut this off here, this metal. Oh, I feel like I'm just, oh god, that was a mistake. Look at this, how I bent the Do you see that dent here at the bottom? You can here see it. That was a mistake. I need something stronger to clip that off. Let's just bend it up, I guess, for now. There's a warning on the tool. Okay, so this one here also has these black pegs at the bottom. They are also to hold it in place on a PCB. So this is also kind of getting in the way right now. When you put that in there, then it's like crooked. It's leaning forward, and it's not really stable. So I mean, we could probably modify this. We could file these off, but this one looks already much nicer than the other potentiometer I had. So I think this is a fairly good choice, but would maybe require some modifications. Let's see what else we got. But we keep this in the inner selections for now. What snipping tools are you used for bending? It's just like a bendy pointy thing. Here's why the voltage exactly. I didn't connect the pull down resistor to one side of the diode, did I? Okay, wait. So is this what I built? Let me show you on stream. Okay, so you were sending me this. Okay, wait. So we have the switch here, and that can be turned on or off. That switch is directly connected to what is that? V, so positive, and then we have capacitance breadboard. All right. I mean that. Okay, wait. Okay. So this goes then into the LED. That's not how I connected it, did I? I'm pretty sure. Wait. Wait, V output. Because I think I connected V output to a resistor as well. V output. Did I connect the resistors in parallel like this? Because this obviously looked completely wrong. Like this doesn't make any sense. I believe, or was this a mistake? Because I thought I connected this one meg. Would it be? Let me rephrase. Would it be correct to connect this pull down resistor directly to V output? See the other image. Yeah, and like I understand with the direction of the diode thing. Well, what do you mean with other image? The last one. Isn't this the last one that I'm showing right now? This is the last image you sent. But yeah, if I would have so this is wrong. I see that. Like this in parallel makes no sense. If I would connect the ground to V output, would it then have been correct? Okay, so let's quickly go to twitch.tv/liveoverflow. Into the videos. There's the other link. So wait, you posted. Okay. Okay. So now you posted a screenshot of your message, and now you let me type off the URL to the image that you want me to see. Okay, wait, so what else did you write? When connecting the pull-down resistor to one side of the switch, then the residual charge can flow through the resistor, therefore the watch drops to approximately 0 volts. Yeah, okay, so this is the setup I thought I did, or I wanted to do, but maybe that was exactly my mistake. Maybe I screwed that totally up and I connected it wrong, but yeah, of course, it makes absolutely no sense to connect the resistor in parallel to the current limiting resistor. That makes absolutely no sense. Of course, that I want this connecting to the output. I thought I did that, but maybe I did not. And if that's the mistake, then good because I stared at that thing for ages and I didn't catch it. So let's see if we can quickly find it. So this was in this charity stream for the blind hacker. So basically it happened, let's see, I did a break. Okay, so it happened before this break here. Okay. Okay, see, no, I connected this different. Why does it go dark when I pause? God damn it. Okay, let me include this camera and then I get a piece of paper. Here, this is how I connected it. And I mean, it's clearly still wrong, right? Because clearly it didn't work. So I guess this way. Okay, so you can see here the IC. The output goes over here. Here's the LED. I forgot what the sign is. And then we have a resistor going down here. So that's the current limiting resistor. But then I have here in the input, I have here a button, and I have connected here a pull, whatever that is, I need to check again, as well as an LED. Okay, I drew this now, a bit annoying. There are two resistors, but they are not in parallel to the other side of the LED, or they shouldn't. They shouldn't be. So there's basically an LED with a current limiting resistor like that, and then this goes. I believe that's how I connected it. Here's the image. Oh no, that's the one you sent. Yeah. Let's see if I can find a closer up of that. See, so if you look here in the left, there are, okay, so, crap, I ripped it all out unfortunately. But these connections should be, so, see, okay, see how the yellow connection goes directly to one side of the switch. Okay, so the yellow input, this is the yellow cable here, goes directly to the output of the switch. I think this is pretty visible. It's for both the case. This one connects to the right side of the switch and this one to the left side of the switch, but doesn't matter, the input here is also reversed. Okay, and then I use the LED and I also go from the output one over, and now look at the LEDs. Do you see that? I'm not sure if you can zoom in, but clearly on the side where the yellow one goes in, if you follow this line, here's one leg of the resistor. So this is this resistor here, which goes at the output where the yellow one starts, goes also a resistor over there. And then if you go one row up, this is the row after the switch, there's another resistor leg. And so this is where the LED bridges one row over, and then there's a current limiting resistor for the LED. You know what? Let's just build this again here. This goes quick. This goes quick. I built it how I thought I connected it really quick. I think it's in here. Take a screenshot of running video. Looks like a voltage divider with pull down. $15K for microcontrollers. Okay, maybe I used the wrong resistor value. That is also an option, of course. Okay, so let's try with. I guess we need both. Wait, this was an OR. So if this was an OR, then we can just connect one side to ground for now. Okay, so this is the wrong color. Okay, so this is the wrong color, but we just use this really quick to connect one of the inputs here to ground. And then the other one, we connect the button. And so if this one, so this one has to be connected to VCC. Okay, so now it works like this, that we have VCC coming in, button, output goes directly into here. Okay, floating state when it's not pressed. When it's pressed, it goes 5 volt inside there. So now what we do is we need a pull down resistor or whatever it's called. So this one here is 10K ohm, which I think is correctly spec'd, and we put that over here where the yellow connection is here. Okay, and then we use the LED and we bridge one row over like that, and now we need a current limiting resistor for that LED. That's 10K. So that's 100 ohm. So let's use this. So we put that in there. Okay, so this I believe was my setup. Or at least that's how I wanted to do. You know, maybe I still connected wrong. Okay, I didn't read chat yet. If you are yelling, wait 1 second. So it's not working. So this here, so right now, this both inputs. So this one input is connected here through this one. The upper yellow one here is connected to ground, so it's pulled low. And the other chip and the other side is also pulled low through the pull down resistor, no? Okay, so if I draw this again, this is how I connected it right now. We have VCC plus 5 coming in over the red one into the switch. On the other side, we have a yellow connection to the input of the IC. Then we have connected an LED, which goes over to the other side there. So the legs bridge over, and there we have a current limiting resistor for that LED. So you can ignore that resistor basically, because that has no effect on the LED. You know, it's nothing. This is just the current limiting resistor for the LED. And then this output has also a connection down to GND. That's my pull down resistor basically. And that's it. And then at the output we have the other LED. Thanks for the Twitch Prime sub, Adam's entity. Yeah, the connections are right, so the voltage should also be fine. Okay, I'm glad that you agree. So what is wrong? Okay, so see, now if you, I'm not sure if you see it on stream. Maybe I turn the light a bit off because we have a little bit of a bug again. So see that it's kind of on. When I press the button, oh no, it doesn't change right now. It just stays on. But I'm also not sure if it's a real on state because it seems a little bit darker than this one here, directly connected, but both own. I guess there are internal resistors as well on this chip. Measure the voltage with the multimeter. Will do, sir. Will do. Okay, so we measure the voltage. So the input is this here to the switch. See how the LED changes the color when I touch this? Like something is floating, something is really weird. Okay, so this side and G and D. So right now there's 1.1 volt. That should be the pull down state. And now I press, and that's the pull up state. It's 4 volt. Is maybe my resistor a little bit too small? Is 10K not enough? Because it's still 1.1 volt, or where's that coming from? Yeah, the second, yeah, I know this gate has internal resistors. I know I wouldn't need it, but that's not our problem right now. So my question is, if with a higher resistor, would this voltage go lower? Because maybe that voltage is just at the threshold for this chip for input. But I believe we use 10K on this build all the time. 10K should be okay. Yeah. So where's this 1 volt coming from? Now here's the thing, you know, I did here basically a pull down resistor. Is maybe, I don't know, should you do does only a pull up resistor work for this chip or something? Like, does something like that exist? I've never thought. I don't know. Like, I have no clue. I'm a noob. Bigger will only make it worse. Why? It would limit even more the voltage. Okay, so you say try with 1K. Is that 1K here? So this is 1K. So let's change the pull down resistor. Let's look at the next switch. So this is not a latching switch. This is just non-latching. The idea was maybe to replace the single press button for the single clock forward. So it like replaces a regular button. And I thought if we use, you know, something like this, a latching one, and then we have kind of like similar looking ones, you know. The blue one is latching and this one here would not be latching. So this would be a regular just clicking, and this one would be latching and would change on, off, on, off. And this one is just always on, off, on, off, on, off. So this one has a little bit, you know, shorter legs or thinner legs. It doesn't, it's not as strong in there. Oh man. Okay, wait, let me read chat. You need a smaller resistor. Bigger one will make it worse. That didn't sound logical to me at first, but then a bigger resistor will cause less current flow, and that makes sense, I guess. I need to pull down more, so a smaller resistor. Okay, that somewhat makes sense. And then Bangpa was saying about an internal pull up, that would cause to have a voltage divider. I don't know. Don't use fancy words. Okay, wait. That was the 74 LS32, I believe. So it doesn't have an internal drawing, at least on this data sheet, or was it blind? There's none in this one here. It's a 74 LS32. Pro GJ, it's just an OR switch, was just to show and like a simple OR. It's an OR gate. Are those keyboard switches? I don't think that they are keyboard switches. They are just, but I thought about getting keyboard switches as well, but keyboard switches are not latching, right? So a keyboard switch would be, I guess, cool for the regular presses, but we want also latching ones. And by latching, I mean you press it, then it stays on, you press it again, it goes off again. While this one is like a regular keyboard switch. And they look somewhat similar, I guess. Yeah. You found an internal diagram? All right. Okay, so let's see if I can make sense out of this here. LS32 here. Okay, so we are talking about one of the inputs here, right? So let's see. Is that a diode? I don't know what is this squiggly line in front of this thing? Okay, so I guess from VCC, so we have a pull down resistor. So from VCC, we have a 20k ohm going down here to A. But then we also have to think that from the button, we have another voltage coming in, also going in here. And now we need to connect that somehow to ground. So we do another one going down here. Is that then called a voltage divider? Because it seems weird, like you have VCC connected to A directly. And then you have VCC connected here through 20k ohm. And then we have we tried 10K and 1K. Do you know where the information is from that JIT is disabled? No clue, but that was some... You can maybe measure this with timing, I could imagine. Maybe you could measure function executions on your desktop PC and see once it's optimized that it goes faster. Maybe something like this could work. Maybe you can come up with a test case and then do the same on the Switch maybe. But yeah, I don't know. I don't know where this information is from. It might also be wrong. I just remember that kind of the talking discussion back when the Switch came out. Yeah, okay. I don't get it. I don't understand. But now I know that if I measure a too high voltage, I need a smaller resistor. That's what I remember now. Okay. Anyway, thanks so much for all the help. I'm glad that we fixed that. So that is still that's cool. So that it now worked. The way it's orange doesn't do much except protect the input, I guess. Wait, shouldn't this be... whatever. Yeah. Okay. Okay, so these switches here. Okay, so actually they are pretty tough from the touch. So, like, they are quite heavy. So I don't think that they are, and they have a lot of travel way as well. I think a small button like this is still better. Like those small buttons here feel still better than something like this. And also this doesn't really hold on the breadboard very well. I still don't understand what the problem is you want to fix. Well, the problem was that it wasn't working. I had a button connected to an OR gate and the output was always high. And I thought I connected it correctly with the pull down resistor for the input so that the OR gate would work. Just the OR gate didn't work. And then we measured a voltage and saw that there was still like 1 point something volt on the input. And that probably caused the OR switch, like that was probably just the threshold and it didn't properly work. So the problem we had was that it was a wrong setup. It just didn't work. Okay, so what do we have here? These are again non-latching ones. Why do you need an LED on the input? Just to visualize the button press. It was for a stream, just as a setup to kind of like show when you press the button there's an LED. But the LED wasn't the problem. The LED wasn't the issue in this case. But yeah, thanks so much, Toby, for all your effort at trying to draw that out and simulating it with the tool and everything. Very appreciated. Okay, so this one is also a non-latching one, and that one is a bit easier on the touch. So that one it's not as heavy. So that could be, yeah. I still wonder if we want something like this for the clock. It would maybe look cooler if all the switches look kind of the same, but maybe it's really not necessary. Maybe it's like, I don't know. Not sure yet, but these look pretty good, so let's keep that one out here as well. That's a good sound. Second ASMR video. Just for blinking lights, correct. That has a good sound, you like that? Okay, what do we have here? Oh, these are weird LEDs I found. So I bought them because maybe... Okay, so look here. So I found these LEDs when I was browsing, when I was looking for LEDs. And I thought they look kind of cool because you can arrange them in like an array like that. And I thought that maybe they are thin enough, because the problem is with our arrangements here on the breadboard is always that these 5mm thick LEDs just always require 2 hole spaces to take up. And I thought maybe they are a bit thinner, maybe they can fit perfectly next to each other on a breadboard so that you can build up like a bar graph like that. And they were diffuse, and I think with the white border, they just look really nice, I think. Unfortunately, it turns out, I tested this already. I can show you, let me grab a few more. Unfortunately, they are just a little bit too thick, so they don't like nicely fit the hole spacing. Oh no, come on. So if you look here, like this one starts now aligned to a hole and then it gets immediately disaligned. Non-aligned again. So they unfortunately don't perfectly fit next to each other on the breadboard either, but they do look really cool, I think. I kind of want to turn them on. I haven't like looked at them yet. I don't know what their specifications are, what kind of voltage they need, but let's just use 100 ohm. That maybe should be enough. Power. Can you stop the clock manually? Yeah, we have a switch that we can switch between a manual clock or an automatic clock. For circuits that have internal pull-up resistors, the buttons should be connected to GND without any resistors nor diode. And does this one have a pull? I guess it does have a pull-up resistor, right? The 20k ohm is a... So if I look at the schematic that we had there, is this basically a pull-up resistor that we saw there? Come on. That's a pull-up resistor, right? The 20k ohm in there. This here. All right, that's cool. Okay, so now I kind of better understand this. All right, that makes sense. I still don't understand the voltage divider or this cascading of different kind of ohms and things, but using the simple way of looking at this and seeing there's a pull up resistor in there, and then we can connect the button to GND. Cool. Okay. Have you tried 3mm instead of 5mm LEDs? I haven't, but they are kind of the same problem because the hole spacing is 2.5mm, and so 3mm would work well for like 3 or maybe 4 in a row, but then they also start to push each other out of the way. And they are smaller, they don't look so cool, I think. Okay, so let's check this out. I don't know the orientation. I forgot. Wrong guess. There we go. In person, they look really nice. On video, they are also a bit overexposed right now. But, and this camera just gets a completely... This is so red in person, but this camera, why is that? Did I select such a weird color profile? This looks like yellow, almost green on that camera. Oh no, I guess on there. Well, I have another color correction happening in OBS, which maybe pulls it again into a different direction. This almost looks like it's burning out or something on stream. But no, it's a really nice glowing red. It looks really nice. Unfortunately, not useful for our build, I guess. It looks almost as it's white. Yeah, that was also the problem with the other LEDs. But in person, it looks really nice. It's a really nice red. Okay, so also uninteresting for our build. What do we have here? This is another latching switch. Oh my gosh, wow, that's a strong one. That requires some force. So here, it also has like, it's not as, like on the side it has like weird stuff. I don't know what this for. Maybe I assume that's to hold it in some places. Yeah. I don't know, but that one requires a bit more strength to push. So I like the bigger base of this one here. It's nicer to press, but this one here just has a better latching. This is like, you really have to overcome. There's some kind of resistance in there that you really have to overcome. And then first you go down. So yeah, not too great for kind of this breadboard purpose. Okay, Toby, I saw the pictures. What do we learn from there? Just that it gets a little bit of voltage still. Okay, not so great. And the problem with this, like I ordered these from abroad, right? So I ordered immediately more in case they are good, that I can use them, and so I had to order more. Okay, so these ones here are also non-latching again, but they also don't have a click. They are just quiet. I don't even know like when they trigger. So this is different to the one that we have here. This is a clicking latch. This one is just quiet. So I think also for our purpose, just because we want kind of a little bit of pressing feedback and whatnot, I also think this is not an ideal usage for us. Toby, but the problem was that the big resistor failed and the smaller resistor worked. Okay, so this is another latching one. They have a slight difference in how they feel like just the pressing down. Not sure which one I like more, but this one is also a good one, I think, in general. They're a bit different. ASMR. Did you see the new video on Live Overflow 2? I uploaded an ASMR. It's not really ASMR. Okay, so this is another latching one. This one is also a really clean looking one. It's just a black body. And I think feels pretty good to the touch. It doesn't sit as strong on the breadboard as the other ones, but it seems strong. Uh-oh. This one looks really nice. It's so because of the simplicity, but somehow the legs are just a little bit. See, and suddenly it falls out. I pull it out. That's kind of a bummer. This is not good usage for a breadboard, I would say. It's not very stable on there. It's even more of an unboxing now. Yeah. Oh, these are the blue LEDs. These are the flathead LEDs, the blue ones. They were so expensive. They were like €1 or so each. And I bought 35 of them. Because the Ben Eater build requires quite a lot of blue LEDs. Please be good. Please look nice for our build. Please. I paid so much. But so here, let's compare them to the red ones. Those were also the only blue flat ones that I could find. They look at least pretty similar, so that's good. Oh, they look like almost it's the same. It might even the internal. Yeah, even internally, the metal. Oh, isn't that macro lens amazing? Even internally, this looks similar. They might even be the same kind. Bought from 2 different stores. Why don't you change the color? There are only so many colors. We already use yellow for kind of like control, red for data. No, yellow is, I don't know, some kind of control. Red is for data, and blue is the clock, and will later also be instructions. So, you know. I mean, why do we build this whole thing? It's to blink and look nice, and the color variations is nice. Nice. How that red LED steals the voltage of the blue one. Yeah, in this configuration it's a bit too bright, so let me try a larger resistor. It looks good, not €1 each. You know. So let's try, I guess 200 volt, 200 ohm next. And then we have so much red already on the board, right? That's why we want different colors. Imagine at one point we didn't have the tech to make blue LEDs, but we were able to do red. Yeah. Still looks so white, but in person it looks really nice. I need to kind of like, I want to compare this to a red one next to it to kind of like see how bright I should make it. That might have been the 100 ohm. Okay, yeah, it's still a lot brighter. So let's try 470 ohm. Look at that baby breadboard. Yeah. They are an accidental discovery, the blue LEDs. Mini breadboard Arduino. Oh, I got one of these. Or like a similar brand. Can't find it right now. I don't know where I put it. Ah, found it. I don't know why I bought it. At some point I had all the available colors of this breadboard in my shopping cart, and then I thought, come on, really, you're spending already so much money again. You don't even have a use of it. You just buy it because it looks funny. And then I decided, okay, let's only get one to see how they are, and we can always then buy the other colors if we kind of like it. Oh, wrong headphones. There we go. So they don't have power lines on this side. Yeah, so they are cute. Like I said, no clue what I use them for. Okay, anyway, so 470 is still kind of light. What happens with 1K? 1.5, 1K would be here. How's it wired? It's like the middle part of the regular breadboard. So now it gets closer to the red one in light. It's still a bit brighter, but it starts to also look nice and blue on stream. So maybe, so if that's 1K, then let's try maybe 1.5K. Maybe 1.5K is the sweet spot. That's a huge resistor for... Also, we have to remember that if we use that on outputs of our ICs, then there are already resistors in there, so maybe we then need to go a little bit higher again. But I've never used such a huge resistor in front of an LED. But damn, that looks good, I think. Wait, I can tell you exactly what it cost. I thought they were $1, but let's see. Oh, €1. Oh no, sorry. I take everything back. 70 cents. 70 cents per LED, and I bought 35. Okay, yeah, cool, but I like that. I think that was a good investment, right? Cool. I like that. Okay. 1.5K, we remember that. Cool. On to the next stuff. Wait, what is this? Oh, that's the breadboard. Okay. Cool, 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 cool. What do we have here? Okay, this is another weird LED thing. I have no use for it, but I thought it looks cool. This is like, now it feels really like a shopping haul. Like this is like packaged some kind of fancy jewelry that you just bought. Like look at that packaging. This is some sleek black. This is like as if I'm gonna propose to somebody. Oh yeah, okay, so these are these LEDs. Look at these. So this is like an LED array. And they look like they are just like diffuse like that. So I wanted to see how they look like turned on. Okay, wait. So we need to remove that and then, yeah, I don't know. Okay, we only have one on. There we go. Okay, so this one is a bit probably too high. Let's, I guess, try the blue one again. There we go. Okay, I don't have any use for it, but it looks really cool. You could really make like a nice filling up bar or something with that. I think that's kind of cool. Neat. How it's like bleeding into other stuff. Did I buy every single LED? Yeah, not by far, that's correct. Okay, so what do we have here? That's another LED thingy. It's hard to tell which one is on and off. Yeah, so it wouldn't be like a status bar like we have on our board, you know, where we exactly want to see the bits on and off. But as kind of a status indicator, like something is like loading up, like a loading bar, I think that would be cool. Okay, so this here is a 7-segment display that just has a lot more digits and has a lot of connections. I hope that they've... Yeah, perfect. Wow, that sits well on a breadboard. That's nice. So this is one of the options maybe that we could use as kind of some kind of output for the computer. So I wanted to buy one with more. This one looks really nice. I don't know the color anymore of this. Was it this here? So this one is red. Yeah, that's a cool one. Let's remove, wait, we don't need this, I guess. Go away with that. You can use each digit with a dot as a byte. You can use it as a bar for the current consumption of the PC. We have another Michael Cera person in here. Are these cathode or anode? I have no clue. Does that matter for us? I didn't pay attention to something like that. It doesn't say on here. Good night. I can't find it really no quickly. No, there it is, I guess. Common cathode. It's a common cathode. More dip switches. Look at this packaging. Okay, so these are just red dip switches because I only had blue ones, remember, and I wanted to have a matching one here. So I got a red one. So I'm not sure yet about. I really like this one, but it would be good to have another blue one up here. Yeah. That one, I'm still a bit undecided which one to use. The one with the long ones or the short ones. But yeah, so these are just a collection of dip switches here. I have ordered, by the way, more storage for all the electronics for sorting it into different things. Unfortunately, it wasn't even shipped yet. I ordered it like a week ago. So annoying. Okay, so here we have just the same flat ones, just in green. The weird white flat LEDs. I ordered them just in different colors because if they were cool for our build, I mean, I'm still wondering if we should replace these with, but no, I guess I like the ones that we have right now. But yeah, I think they could also be used for a cool build that looks nice. What do we have here? I didn't realize how long this unboxing stream would go. Holy shit. Oh my god. Okay. So here are also just, these are 2 digits. Yeah, just regular 2-digit ones. How much money did you spend? I don't wanna say what I spent on this order. Did you fix the cable colors? Oh, don't make me feel bad. No. It still makes me mad that we used blue wire here and we should have used green. But I refuse to redo this now. This is, I think, that would be a bit too crazy. Like I said, we might redo the RAM module in its entirety anyway to use more RAM. Then, because all the 3 breadboards that are blue right now are the 16-byte RAM. So we might want exchange that anyway. And when we do that, and build the new one, we can still use different color, but I leave that for now. What's your opinion on assembly? I don't understand questions like this. They don't make any sense. So this is again one of these, just yellow. They look so nice in real life. It doesn't really come across, I think, the color on this camera, definitely not. On this camera, barely. But in person, they are just such a nice color. Those are debate questions. Yeah, maybe I should not fall. I need to start ignoring messages. I still keep to be, yeah. Okay, so here, this was a weird one I found. And this one was also a bit expensive, cost like €1 or €1.50 or so, or, you know, just an amount where I didn't want to order multiples of them, but I did want to try it out. Look at this one here. Come on. This is like the linear one. It's also an LED, but it is like an array of 4. 1, 2, 3, 4. Just like arranged like that. So here, the top right corner is on. Wow, it's crazy. This is so red. And this camera, I don't know what I did to this camera to change the color profile. This red is not coming through at all. That's insane. Wait, let me see. I can, when I have the USB connected, the settings are just screwed up. Can I also adjust the... I need to change the presets. Maybe I should get the ISO as a way to adjust. When you get around expanding the RAM, you expand it to full 256 bytes or even 16-bit addresses. Yeah, I've been thinking about that as well. That would also be kind of cool to have. If you have 16-bit addresses, you could really do a lot with it. Then you could really run nice programs on there. But that would, I mean, it might even be fairly simple. We just basically add, I guess, 2 more registers, make our instructions 3 bytes long. The instruction decoder gets a bit longer. And we just use 2 registers as the address register. So it could work. Maybe it's not that hard even, but yeah, I don't know yet. The problem with all of these questions is that I still don't really understand how this whole computer works, especially like the instruction decoding and fetching and all that kind of stuff, how that works. Yeah. Yeah, that's hard. Like, I mean, what we could do is, if we also do the instructions, then we need a 16-bit instruction register as well. And a 16-bit instruction register and an 16-bit address register, I guess. We would need then to do both. And we both has to be somehow, then we can't use the bus anymore because the bus is only 8-bit. Then maybe we need to extend the bus to 16-bit. That seems a bit crazy. But yeah, maybe, I don't know. Let's figure this out later. This is a discussion we should talk about in like a year with the speed that we are going right now. Okay, this one is another non-latching switch. It's a bit smaller and it's non-latching. I need to exchange the battery here. The wire count is getting pretty big. Yeah, that's the problem. Oh no, my ID is leaked. Oh no. Oh wait, I didn't even look at this. Okay. So this one again is like smaller. The spacing is a bit too small for the breadboard. It also doesn't have a clicky sound. So I also think that for our build is not so good. The 6502 uses low and high byte for address loads and address byte by byte. Yeah, but then you need to complicate everything. So if you have to use the bus twice, you always need to have logic that stores, like you need to have some flip-flops or registers on the, I believe at least. So for example, the RAM module would then need 16 bits at the input, where a control signal will first load the first in and then the second one. And so yeah, I mean that could also work, I guess. Maybe I don't know the extent yet. I still don't understand too much. I have never, did I buy it? I might have ordered something on AliExpress before, yeah, I guess. Not much though. I'm impatient, so I order. Yeah. Okay, so these are also just 7-segment displays for the output here. Nothing important for right now, I guess. We deal with those when we are adding one of those to the build. Okay, now I have another potentiometer here. I thought this would be maybe a cool idea, but I also checked this really quick, it doesn't match. So this is another 1 meg potentiometer, but look at this. This is kind of cool, isn't it? It's a wheel that you can adjust. So it's not a turny thing like this one here, where you turn it at the top. But it's a wheel, and I think that's kind of cool, isn't it? If that would sit there at the top left of our build, up here in the corner, and you could like turn that wheel to change the clock speed, I think it would be kind of cool. It's meant for radio. Yeah, could be. I mean, it's an adjustment wheel, right? So I like that idea. I think that is cool. The problem is just look at the pins. They don't fit a breadboard. So yeah, so not quite sure how to deal with that. One option we have is, and Ben Eater did that also for his switches that he has, is to extend the bits, like put solder some proper pins onto this here and then plug it in. Now it would be a little bit raised, which also wouldn't be bad because this is like super flat. So if it would be a little bit raised, I don't think that would be too bad actually on the board. It might even be better and more usable. Not breadboard friendly, yeah. How can we change the frequency? The clock basically works with a chip that capacitors can store electricity, and so they charge up, and when they are charged up, they release again, and then they charge up again and release again, charge up again and release again, and that creates our clock signal. And the speed on how fast they charge up is dependent on resistors that you place in there. High resistors mean it charges slowly, small resistors mean it charges very fast, and that gives you how fast it charges and get the clock pulse basically. And that's why we added this into our build, that we can adjust the resistance. This thing can change the resistance. That's a potentiometer. And so we can adjust how fast this capacitor is charging, and that's deciding how fast our clock will run. But again, this is all based on Ben Eater's video series. If questions like this are perfectly answered by his video series, so I just encourage you to watch his videos. This is how the Game Boy speed hack. Oh, that sounds cool. Oh, that's kind of fun. Right now, we are going through stuff I bought. Okay, so this is kind of cool. I do want to experiment and see if we can solder something to this. Because I do really like that wheel. I think that wheel is really cool. So this is another option for a potentiometer that we could use. Now I lost the other one. Oh, over here. Oh, we need to reset the wires. We didn't do anything today. Okay, so what do we have here? Oh, that's another 7-segment display. I believe it's basically the same one that we had earlier. Oh, no, it's a bit different, I guess. Look, it's black. It looks really cool. And this one is green. So that's a green one with a black top. So I also think that looks kind of cool. Again, I think we will explore these 7-segment displays once we reach that in the video series, because they are kind of cool, and it would be cool to see them actually working instead of just fiddling around with multiple wires. So yeah, we can remember that as well. We're almost through the last 2 items, basically. Okay, so these are also just 7-segment displays again. These ones are, doesn't say the color on here. But they also have a black finish. I really like that. Wow, the kind of packaging some of these things come in is really crazy. Oh no, it just looked like I'm an idiot. It looks so dark on this here. It's a normal one. Yeah. All right. Just also 7-segment displays. Things for later. Not even using Nixie tubes. Yeah, Nixie tubes would be cool. It's crazy that this whole Nixie tube trend started when Dave from EEV blog started building his Nixie tube clock. Was that the trigger for all these Nixie tube memes, which just happened like a while ago? Okay, and then we have another latching switch. This looks very similar to this one. What is the difference here? What is the difference between those two? Oh, I believe they have a slightly... No, do they? They look like just the same. Okay, so here are the other ones. So what's the difference here? No, wrong label. Yeah, definitely two different ones, like from the name her, but maybe it's the same manufacturer, just a different like brand labeled the same thing. Who knows? So the price theoretically for the parts is around that, but I've spent so much more on the stream. Like with all the crap I've bought since I started streaming, I'm down quite a bit of money now. But it's fun. It's like my hobby, right? And also, why I bought all this stuff here today is to select good parts that make this PC look nice. And so, you know, as a good tech product reviewer, I'm reviewing it so other people can make good buy decisions. So later, I hope I can assemble a nice parts list with really nice switches and buttons that just make it a little bit nicer than if you just bought some other parts. The unboxing video is now longer than the mailbag segment from Dave. But I also spent money on some weird stuff like a FLIR camera. That was expensive and unnecessary. Should I demo you something that is also upcoming that I want to do, but not today on the stream? How long have I been streaming? Almost 2 hours. All right, crazy. I have a label maker. It's not here right now. So we use the label maker to label boxes and stuff at home. And I've seen somebody label all the switches, all the chips with their name, so that you can just from a more distance look at it and see, oh, that's the part number. And I think that looks kind of cool. So so I just bought a couple of different colored labels for printer. And then, so this is another thing we play around with some other time, but not today. Today we already procrastinated building a lot. I want to continue building, so at some later point we do another maintenance, making it pretty stream, and then we can check out the label printer to label the different components and label the different chips. Yeah. Are you going to upgrade? Yeah, we plan to, but no clue yet what and how we do it. Yeah, no clue yet. All right. Cool. Oh, wait. Okay, so now we need to, I guess, select different switches. Okay, so... They are pretty much identical. Except this other one has a small print at the bottom. See how on this side there is a little bit of a imprint? That's the only difference between those chips that I could, between those switches that I could find. What do you count to do with the computer you're building? Nothing. It will just blink and look cool and learn. It's a learning process. Okay, so I guess let's try to replace. I think these blue ones are nice. This one here is just, I don't know. Okay, wait, you need to vote. Tell me. Okay, so let me give you, tell me, explain to you. Okay, so we need to decide between this one or this one as a latching switch to switch between the clock or the input and output selection here. They are both pretty much the same size. This is just a tiny bit bigger, but it doesn't really matter. Almost same form factor. They have different clicking sounds, so now you need to listen. Wait. ASMR clicking. Okay, blue one. White one. Blue. White. Then this one here, because it is like a little bit of a corners here. You see it's like not completely flat, so that feels a bit pokey on the finger. While this one is really nice and flat, feels a bit nicer. However, this one is easier to press than this one. This feels like you need to put a lot of more force on it, and it doesn't feel as switchy. I don't know what to say. Okay, so wait. We have 1, 2, 3, 4, 5, 6 for blue, and 1, 2. Oh no, somebody else on my ID. Crap. There won't be a button on it. It's like that is the one that we will push forever. I assume, at least. Okay. So many people said blue. I'm curious. Okay, I mean, so many people said blue, then let's do it. So up here, so here we need to put it in. Now there is not enough space. It doesn't go across the breadboard here. It's too small. So what we need to do, we need to plug it here on this complete side, and then there are cables in the way. So we need to deal with that. So okay, so my trusty, so this small cable we can definitely move over here like that. And I guess this cable we can also move over here. Like that. And then we have the problem with the long cable, but I guess we built a new one that just has a different kind of path there. Why do you mean Forsen emotes are banned? Oh, the auto mod. I don't know why the auto mod. It's probably because of KEK, to be honest. Probably because of KEK. I don't know, but why is Forsen low? I don't know. Like, I didn't configure this bot. I mean, I set it to like, you know, I don't like toxic. Like, I will. This is a communistic dictatorship that is being run on this channel here. So rather catch a bit more than a bit too less, I guess. But why this particular, I have no clue. How can we get this knowledge of electronics? Just do it. Buy an Arduino. Build a blinking light, I guess. Then you can join us in amateur electronics. I mean, this is all very amateurish. Okay, so this goes over here. Okay, so let's take this out. Top pin there goes over there. Okay. Oh God. So I guess we move it all the way over here, or we could maybe go on this side because there's not much green. Let's go on the other side. That will be, and then then it's a bit too short, I guess. So if we go like this, then up, then over here, then down, and then like here. By the way, somebody in chat mentioned like a an Australian minister or something, and said I look like him. That was the first that I heard that, but I had my suspicion. I thought maybe that person looks like Michael Cera, and so I typed in that prime minister or that minister's name with Michael Cera in Google, and then I found people saying, "Don't you think this minister looks like Michael Cera?" And then I thought, now I know why people say that I look, why this person said I look like him. It's so funny how people get triggered by this. It's just a plastic card. Like, this is not an ID. Like, this has no value. This is nowhere an official ID. It's nothing. It's just something printed on a plastic card. It's nothing. I made that as a joke because people were saying I look like Michael Cera. That's a super old picture too. Like, this thing here was made in like 2012, I believe, and that picture was at that time even older. Staubfinger, if you don't know this, you can make them. There's always a booth at C3 where you can make these. It just costs a couple of euros. It's not that expensive, like 10 or 20 euros or so. Then they make a photo of you, and then you fill out whatever you want on it, and then they print that for you right there. Who would have thought that it comes so handy years later? Okay, so in here, and we go up, and then we bend right here. No, they don't make fake licenses. That would be illegal. Like, what are you guys thinking? Of course not. They don't print whatever on it. They print, it's not fake or anything. It's just their own design, and there's nothing like fake about it. It's not an official document nowhere. Of course they wouldn't print something on it. And of course it doesn't have any security features, like no holograms or nothing. It's just a plastic card. This is literally just the printer that you can buy to print on plastic cards. Like, ever wondered how hotels have their own cards? You just print them. You can buy such a printer on Amazon probably. I also thought about buying such a printer at some point and making stupid cards, but oh my gosh, will I buy now one? Oh, I shouldn't say stuff like this. Okay, and then we go until like here. Have another bend. I remember primary school, we went to a business card place and all the kids got 100 of a custom design. Oh, that's cool. Lichtbild is like a fancy term for photo. It's like a picture made from light, I guess. I think that's just a very old German kind of old school word for a picture made out of from like light photography. I think photo ID, Google, yeah. I think Lichtbild is like a very like old German word for like a photograph. And then Ausweis is just identity card. We almost did a cable today. Oh wait, it's just a replacement for another cable that doesn't count. Okay, cool. So I think that's it. Let's see if it still works. Oh, we forgot the potentiometer now in the corner there. Nice. Okay, so the clock is blinking, and when we press the button, it doesn't work. Yeah. Oh, connected wrong. Now it works. Okay, now we have the blinking, and now we can switch to the manual, and then we can go back to the blinking. So the one thought I had. Okay, so now you need to decide another thing. Okay, so we can switch now nicely between those things. That looks good, I think. I like that. Okay, so the other idea I have is this one here. Remember, this was the ASMR switch. Wait, I need a thumbnail for YouTube. Is that a good thumbnail? Okay, yeah, so the idea is to use this switch because it's non-latching. So it's just, you push it and it just, does stuff. And so this one could replace this here, this one here. But these ones are nice to touch. But I wonder, now to make another of these ones to make it look better. So you need to decide now. I don't know. Oh, you can't see, sorry. So this one here could replace this button. So this is just a single press button and it does feel nice, right? These are great. You can also be like very fast clicking there. It works really nice. Like you can be super fast, but we could replace it theoretically with this kind of switch. So what do you think? Should we use the button or okay, wait, this doesn't work. Probably need to connect. Or should we do it like this? The cable underneath is right now obstructing it a little bit. I guess, wait, we can move that. So we could have like this button here. Switch your button, please, right now. Switch your button. What do you think about this one? Okay, wait, I need to decide. Sorry, I cannot leave this to chat. I actually really like this. This is really cool. This feels nice. We can switch here between, and then we can... Is this annoying? Is this too loud for the stream? Everybody's saying button. Huh. Everybody's saying button. A cookie clicker on hardware. A clicker game in hardware. Damn, there's your next product idea. Why has nobody made that yet? A cookie clicker as a Tamagotchi. Imagine the fidgeting. Oh my gosh, this has to be a Kickstarter. Somebody make this a Kickstarter. I guarantee you. I'm gonna pledge. I would buy that. I would so buy that. Imagine a Tamagotchi cookie clicker. With an idle component to it, where it just by shaking, it counts 2. So that would be if you are walking around and you can't fidget with it and you are walking, then the steps still somewhat count. But shaking would be worse than clicking. So if anybody of you builds this into a product I want in, I have investment money. If you have experience with building product and shipping products and getting this to market, I'm so in. That would be such a cool product. Never post ideas online. Well, the problem is I would have never the patience to do that. I have so much other stuff going on. But I'm telling you, if anybody of you runs with that idea, I want that you give... Who said it first? Who said it first? Mikey. So Mikey needs to get at least 10%, and I at least also need to get 10%, okay? If you make this, right? Like, that's a contract you just entered. Yeah, we make that product by hand, and we build this always on stream, and we will make like one product a week, and so it has to sell for a high price. So it's like a cookie clicker for like a 1,000. Where does your effort come into this equation? That's not how this whole capitalism works. There doesn't need to be effort to make money. I provided the communication platform. This is a think tank where we inspire each other and come up with billionaire ideas. Well, NewFlow, you need to make this really sleek, right? It doesn't have to. It's not a 3D printed case. I mean, that's okay for the prototype, but it has to be an aluminum brushed case. The button. You need to review all the different buttons that exist in the world. You need to source them from all over the world, trying to find the correct button. You need to make customer reviews and customer service. You go onto the street and ask people to click it. What is the most satisfying click? You go for the perfect push. You go for the perfect sound. You need to consider different strength of people. You need to consider how they might play it, right? Does it fit into the pans? Can they click inside of the pans? Is it quiet enough that they can click while in a meeting or in school? Like, this is not a simple thing, Don't underestimate this. Maybe you even, Cherry MX, exactly. Maybe you make it customizable that people can select the kind of clicker they want. Like, this is not a simple thing. Yeah, keyboard switch. That's a good idea. I like this brainstorming. We need to get a whiteboard. Where's my face? We need to get a whiteboard into this place. Yeah, the microtransactions, we somehow need to do this, but I guess it's like real world microtransactions, right? We you can buy different, the switches will be exchangeable, so you can put in different cherry switches, but you need to buy them through us because they come with a custom keycap as well. And so that very cheap switch we will upsell, we make like at least like 10 to 20 times more expensive than the original switch. Loot boxes, so it's randomized the switch you get, and we figure out which one is the most satisfying clicking, and so you have a very low chance to get that particular switch, and then some people open it up and realize it's just cherry switches, you can just buy them cheaper. Oh, I like that. I like that. Planned obsolescence. Only last one wants to switch. Yeah, there's a counter inside that counts how much you clicked, and then you need to exchange the switch and buy a new one. And then people realize that they just need to plug it in and plug it out and plug it in again, and it works again. But we don't tell those people. We tell them they need to buy a new one. Dude, this is such a good idea. Like clicking and seeing those LEDs over here. Like here the counter. Ah, crap, I disconnected here the reset. There you go. This is so satisfying. I could do this all stream. Should I do like a 24-hour stream? Wait, how? It's just 8 bits, I guess. That's easy, I guess, to do. Maybe we do like 16 bits, and then we do this on like a very long stream. This is amazing. Well, now you're just joking, missing a crucial part of blockchain. Be serious here. This is totally serious. This is an important product that I want to see at market, but it needs to be top quality. This is not like a $10 joke toy. This is like a premium product with a premium clicker that looks very sleek in a nice metal casing with good LEDs. The clicking was researched. I see the Kickstarter campaign video right in front of me right now. No, not open source. We want to make money on this. It will be secret. Everybody working on this project has to sign a strong NDA. Nobody except us here in this room are allowed to know about this. Hall effect switches. Anyway, no, I mean, I'm partially joking, but I'm partially serious. Like, to be honest with you, a switch like this would kind of be cool. I think that would be cool. Let's exchange that blue LED up there. I mean, there exists already that fidget toy. Did you see that? Like this terrible toy with the fidget cube that has like different sides to it that you can use for, you know, fidgeting. That one was already like super popular on social media, and like basically adding to that a game mechanic would be kind of cool. Yeah, so here, fidget cube is it called? Here, it's like a cube with different kinds of buttons and things to push and turn to fidget around with. But this, I think, looks a bit too cheap, you know? Like, it looks like a toy and it has too much variations and it's not gamified. We need this gamification with it. Wow, what kind of... How large is that one up here? God damn it. That's 1K. Okay, so 1K with the other resistor. Yeah. Okay, 1 second. I will be right back. Welcome back. Thanks for playing. I got brought food. I have guacamole and chips. Damn, now I kind of want to stop streaming and eat instead. You want some food ASMR? Wanna hear me chew? I mean, they are pretty crunchy. Okay, wait. I need to always keep the YouTube thumbnails in mind. How was that? Oh, that's so good. Tastes so good. And I have salad here as well. This is a mukbang stream now. Okay. Let's finish that blue LED over there. So the 1K resistor was kind of darkish. It looks kind of blue, but it's still pretty dark. 1 second. Okay, so if that is 1K, then let's try like 470 again. What was that here, by the way? Oh, that's 1.5K. How's that blue? I think that blue looks better. Let's compare like to the brightness to the other LEDs, the red ones and the yellow ones. What do you think? That blue is Discord blue. Yeah, I think that's good. Okay, awesome. I like that. So this one was 1K. So we put that in here. Excellent. Oh, okay. So and then we have the other switch down here with the dip switches. I'm still not sure. Crap. I feel like I need to order again to replace. What? Okay. So what do you guys think? Red versus the blue long ones. So these ones here or this one here? Okay. No, whatever. Red for consistency. Red, of course, toting. Blue, red. Okay. Okay, so I know it matches the other red. It looks way better because it matches the other red, right? But considering that I could order another one, do you think like if that would also be blue up there? I don't know. The red does add a bit more color, right? It does look kind of better with the blue wires here having the red ones, the red dip switch then. Yeah, I can kind of see it. Why is this? I know these legs are not the greatest. I know. Okay. Okay, and then I would also replace the switch. Was it this one here? If it was the same dark blue, it would be nice. Can't you change that in 3 seconds? Why do you need to decide that now? Just put one in and move on. Yeah, I know. But at some point I need to decide, right? If I spend now the time thinking about it or later, same difference. And so we have here now, I guess maybe let's put it up here. Maybe it looks a bit nicer. Oh yeah, and we have the switch up here. This is also what we need to exchange. Here, this switch here. It's so it's kind of interesting my different behavior. I observed that kind of in myself. If I would build this by myself, I would not care at all. Like I would just, I don't care. I would just continue building. But because it's for stream and because I want it to look nice for the stream, maybe hang it on the wall. I take it more as kind of like a visual experience as well, kind of like an art piece. And so, yeah, I don't know. So I feel like I want to invest a bit more into that. Another CTF stream like we did yesterday. That was kind of fun. I guess with the next CTF that I'm playing maybe. Okay, so we need to move maybe that blue wire up here. And then we also need to move that out of the way, like here. Did you like the CTF stream yesterday? Was it good? I've condensed that CTF stream from yesterday, or at least this one challenge that we looked at, and I will publish this like, I don't know, tomorrow or so on the Live Overflow main channel. Okay, so let's see. Okay, so this switch has a weird connection now, like both are on. I guess we want to Why is the switch behaving so differently? That is so weird. Oh, is that maybe the difference between the two switches? Wait, is that maybe the difference? No, okay. Ah, crap. I guess we need a different circuit for this one then. It's like not toggle left and right. It's like... So I thought it would be if it's like out, then middle and left is connected, and in, middle and right is connected, but that's not the case. It seems to be always connected when both are down. I was told to not work on a circuit when powered. YOLO. It's an on-off, not an on-on. I could have sworn that this was an on-on though. Let's see. Let's look it up really quick. I mean, it doesn't, not that it matters, like we just confirmed that it's not the case, but. Crazy to think that our professor was always recommending this channel to the whole class. What is... Okay, wait, why is it crazy? Because this is complete amateur crap now? Or did he really recommend the Twitch? Or my main YouTube channel? That would hopefully make more sense. Okay, so here, these are the different switches. See? And they have on and on in I forgot what it meant. I looked it up. What does that mean again? On in. Okay, wait. Let me measure this really quick. It should be, yeah. So this one is the 800L. So it would be this one here. Okay, wait. Let's measure really quick. Okay, so when the switch is out, left and right are connected. Maybe it's which side. So it's like kind of like this. This is on. This is so terrible. God. Okay. So left and right are definitely not connected together. So let's see. When okay. So now the left side is not on, and now I would assume that this side is on. Now there's nothing on that side. What? Okay, both sides seems to behave the same. I'm confused. The brackets are latching. Are non-latching. Ah, yeah. I googled this. I forgot again though. When I ordered these, I was also curious. I searched just like parenthesis, and then maybe did I search for switch? What does on mean? On bracket mean the toggle is spring loaded and has to be held in this position. So if there are parentheses, then it's non-latching. Okay, so wait, I'm still confused. Like, how does this then? So this worked up here because up there we only connected like one side to the switch. We didn't connect left and right, but that should work, right? We can also, I guess, look into the data sheet somewhere. So in one side, it should connect middle to each side. Okay, wait. And what is the other on state then? It doesn't seem to be connected anywhere, is it? See? Free should connect the left and the middle, and push should connect middle and right. That's not what I'm observing here. 1 second, I'm just doing a test build down there. And we need a little bit less voltage. Okay. Wait, what? Wait, why? Oh, wait, I connected this wrong. Okay, there we go. Wait, what? I guess this is not connected fully. What the heck? So this is the other switch. This is the old switch, left and right. Interesting. Oh, I get the connection now. This is not the case the same with here. I wonder if this is true for the other switch. Like I have two different brands here, right? Let me quickly get the other. Was it this one here? So see, wait, my observation, can't really show this. So see that when it's pressed, the left is on, right? Ah, crap, sorry. I'm so sorry. So when it's pressed, the left one is on. Okay? So this means it connects middle to this side of the switch, right? Now let's turn it around 180 degrees. So now it's this side here, right? Middle and this side. And this one is on. So this means that on these pins, on this side pins, middle is connected to the right, and on the other side the pins, middle is connected to the left. And that's how you get the switching between each other. So when it's out, these two are connected, and when it's in, these two are connected. And when you have both on them in it like this, now obviously, yeah, it's on both sides like that, you know? Why would they do it like that? It's not the same as in the description there, is it? Maybe that one is just broken, or like, I don't know, maybe that is just faulty. Let's see how this switch behaves. This behaves the same way. See, one side of the pins, other side of the pins. That's weird. Okay, so these ones are the blue ones. So this one here is non-latching. Let's check the other kind of latching. Potentiometer. LEDs. Oh, I guess the other ones were the smaller ones that didn't fit, so I threw them away. Oh no, this one was also a latching one. Let's see how this one behaves. Okay, this one is back and forth. Okay, maybe we use the brown one, the white one, instead of the blue one then. That's strange. Let me plug that in up there. Oh, it doesn't hold very well in the breadboard. Oh, that's a bummer. Oh no, I bent this cable. I guess I could place it on this side. No, it's very dodgy. It's very dodgy. But this one, oh, and there jumped. So this one does the switching back and forth. Unfortunately, it's very dodgy and it immediately jumps out. 132, 132. The pin out. Whoa! What? Those are massive trolls. Holy! Wow. 132. That sucks. But that also means it's unusable on a breadboard. You can only use it for on and off, but not for on. So in our case, it works up here, but it doesn't work down there. Oh, that's a bummer. No, how would you do that on a breadboard? It doesn't work. If you orient it that way, then you have the connections. Like if you put it that way in, now you are screwed because the pins are now no on and off. And if you turn it this way, then you don't have a ground connection. I wonder if it was intentionally designed to be difficult to put on a breadboard. Yeah, it's probably like these hardcore electronics people that were thinking, oh, look at these damn amateurs on Twitch building like stuff. They have no damn clue. Let's make products to screw them over. Oh, no breadboard cam. God damn it. I really need a view of my stream also in front of me here. I can't place them on a breadboard. You can't put them on breadboards. This orientation, it's just on and off, and this way you get a short circuit. There's no ground connection now. Now it's just a 2-pin switch, and the 3-pin version like this doesn't work. And it's too small to put across the middle here. See that? That is not wide enough. They like blue. Let's troll them because they can't read data sheets. Yeah, stupid amateurs. Sorry if I didn't make that clear about the width of it. Those were all non-latching. Yeah, okay. That's a bummer. Okay, so the white one would be cool, but unfortunately it's a bit dodgy on the breadboard. That's the problem. See here? Like, it seems to fit okay, but if you use it a much, see, bam, it jumps out. I mean, not that we would... Okay, I guess on this breadboard here, it's really just a switch back and forth. We don't use it much. We just do it once and it's fine, and then sometime later we turn it back on again. I guess it's not a heavy used switch, but in later we could, yeah, I guess we can use it for now. I guess it's good enough. Oh, it's really, especially with the other wires there, they put a bit of pressure on it and to push it out. So maybe I need to... push these wires a bit out of the way. I wonder if you could put a tiny bit adhesive on one side of the pins and let that dry, and then it's just like a micro millimeter, like just like a tiny bit thicker on the one side of the pin, so the other ones stay connected, it's all fine, but the one side then loses connectivity, but that maybe creates enough friction to hold it in place. Do I have a glue here? I guess I do. Yeah, let's experiment with this. Let me just, this is so scuffed, but okay, so I sacrificed one chip to test this. Let me take one here. Where are the other ones, by the way? Oh, here they are. Okay, so let's paper. Where's the paper I used earlier? Ah. Okay. I don't know if that works. I don't know if that's a good idea. This is just a test. So I'm using here some wood glue. That's the only glue I could find. So the idea is that if we just coat the one side of the pins. Oh my god, I got it on the breadboard. Ah crap, where are my paper towels? Somebody stole my paper towel roll. I guess I have some. Stop judging me. Okay. So the idea is to coat the legs with a little bit of only on one side, because it might, obviously it will lose kind of like connectivity. Maybe I use thinking of how I can apply this. Maybe that's a good thing. So the idea is to just add a little bit on one side and let that dry overnight, and hopefully that just adds a little bit of thickness to it. So when I put it into the breadboard, that it will like stick. Is that a dumb idea? See? So these ones here are now a little bit coated, and I let that dry. And then maybe that coating just adds enough friction that this switch doesn't go out anymore. So I put this securely. Please remind me if I forget about it, that I put it on top of my power supply. We are so smart. I could bend the pins instead. I felt so smart for just like a minute. Yes, they are isolating, but they are mirrored on both sides. It doesn't matter. That's why I only apply it to one side. A small solder coating. Ah, that's also smart. We could have just applied some solder. I'm such an idiot. Okay, let's try the bending technique. Okay, so this is a review channel. Okay, we explore different options to solve this problem. And then I can make a YouTube video that's 20-minute long out of it and get €5 ad money, okay? So let's try a bit of bending. Just like a tiny bit of bending outwards. Maybe this was already too much. We will see. I just bend it a little bit. And now let's plug it in there. Okay, it holds much better. Maybe if I add a little bit of bending on the other side as well. Okay, it's much more secure than it was before. Like this is already like really, it jumped out again. It's pretty good. Okay, it's pretty good. SPDT, I have no clue about switches. Bent it. It's bented. Okay, okay, so I guess the third option is solder. A little bit of solder. I lost the switches again. My gosh, this is awful. What a mess. Did anybody see where I put the switches? Are they right in front of me? Am I blind? They are right here. Why you need to press it more than one time? Because it's supposed to be pressed. And I want it to be secure in there. But yes, it's probably good enough for the rare usage of that button. That's probably fine. Okay, but let's apply solder. It's a review channel. I got stuck in my cable. I'm looking for some solder equipment. I don't know where I put it though. I'm looking for my trusty holder thing. Anybody seen it? Ah, found it. Plastic out of the way, we don't want to die. That's probably good enough. I haven't used this one in a while. Maybe I should dust it off. Okay, so let's turn this on. Oh, this is not connected. Oh, god damn it. Okay, so wait, I need to unplug something. What do I unplug? Right, I needed to order more. Okay, I need to unplug. Oh no, what do I unplug now? I have the choice between the power supply or the monitor. So I guess let's go with the power supply. No, where's the button? Okay. So let's see. Now you see my amazing soldering work. I don't even know how you code something like that. I solved one challenge mind test. I guess I could have shown that also on there. So I added some solder already there at the top. Yeah, I think that's already good. Okay, turn that off. Put this away. I think that should already be good. Let's see. Oh, I didn't check. There's one that has a little bit now of a... Okay, it's fine. Okay. Yep, that feels great. That seems very secure. Doesn't jump out anymore. Good job. Who was that? Selaith. Was that you? Okay, solder definitely better than bending, but we haven't tested the wood glue yet. Okay, trust me, it's the best solution. I came up with it. Incredible work today. Incredible progress. Unbelievable. It's time for me to end the stream. We're over 3 hours in. We did a massive shopping unboxing haul video. We made some good progress. We added a blue LED here. Let me turn on back the power. There we go. We added a blue LED here. That was amazing. It's a new flat LED. It costs 70 cents. We exchanged some buttons. This is the new ledge button that can switch between the... What is so dodgy here up right now? Is it just the LED? Some connection here is dodgy. So this one works. So why? Is it that switch? Is it the switch? Wow, okay, I guess the switch was dodgy. Okay, we needed to exchange it anyway. We wanted the same color switch, I guess, anyway. Okay, so we exchanged the switch to switch between the automatic clock or our hand clock, and we also have a nice clicky switch now here for the hand clock. We prepared the clicky switch down here, which we haven't used yet. We exchanged the dip switch here. Now it's red, so it matches the other dip switch. Wow. We learned that there are green, weird looking breadboards. We played around with the baby breadboard. Incredible. Maybe it was poorly connected. I don't know what the deal with that one is. Maybe it needs a debounce. This is the circuits up here are debouncing circuits for it. So that should be fine. Three hours of very, very, very hard work. Yeah, maybe it needs solder. But anyway, we want to use this colored switch anyway. Okay. Yeah. Thanks so much for hanging out with me. We got an amazing $1 billion idea, the cookie clicker, today as well. Okay. Yeah. Okay. All right. Thanks so much for hanging out with me. With the next stream, we definitely will continue building again. Next stream, we continue with the RAM module, the address selection down here. It's pretty far already, but we need to still add some wires there. We continue with that, and so yeah, hopefully we finish that. We tackle this next stream. Yeah. I plan to stream tomorrow again, but here's wait. Here's the problem. My sleep schedule is completely fucked right now. I got up today at 7 p.m. and I went to bed at like lunchtime, like noon or something. And I have a problem. I can't go to bed now because I'm not tired at all. I just got up like 4 hours ago or so, right? Okay, a bit longer. 6 hours, I guess. I can't sleep now. It's easier for me to stay up longer than going to bed earlier. But if I stay up until tomorrow, like, you know, until tomorrow, like 3 p.m. or later, to like slowly move my time back into normal times, like just moving, always staying up a bit longer, and to readjust to normal times. That would mean that then at some point I would sleep during the stream time, or it would be like super late for me basically when I would start streaming, and during that times my brain doesn't work. I wouldn't be able to stream. I'm so tired then, and I need to push myself a couple of hours more. Wouldn't be able to stream. So there will be a day that I have to skip because of that. Or I stream at super weird times. Maybe I just stream at a weird time. But yeah, so yeah. Like I said, no schedule for the stream. We will see what happens. I have a good alarm app. I'm very satisfied with my alarm app. It's a very smart alarm app. I'm happy with it. Yeah. Okay. Again, thanks for hanging out with me. It's time to go. It was fine for 3 months. Good job. That's a long time. Okay. Bye-bye.